Evolution. Radio. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hey, this is Dave, and Meckie's here too, and we're Shady Side Out. This is the second hour, and we're talking about the hypothesis and the epiphany, part 3, in celebration of our 600th show.
Which will take us through to our 700th show.
Yeah, pretty much. It's a long journey, this one. Anyway, so I want to say you need to get yourself some merch from the station's website. You can do a whole bunch of really cool things. There's things on offer there. Buy something, contribute. You can donate, and that's really good if you can. Yeah, just going to say thank you very much for listening, and don't forget to jump in the archives and maybe get some show coverage of things that maybe you're not currently listening to. If you only ever listen at a certain time frame, you only hear certain shows, but there's so many shows, and you know what? I want you to be the smartest person in the room for any topic. And if you can listen to enough shows and learn enough, then you can tell someone that you heard that on Revolution Radio. And you can increase the listenership, and that's something that we ask everybody to do. And look, do what you can. Donate, tell a friend. And that's pretty much it. Meckie and I are broadcasting. I don't know if you can hear an accent from both of us. We certainly don't sound like we're from the US. I've got a little smattering every once in a while, Meckie. Someone says, "Oh, I can hear it in your R's," right? And I put that on then. But I normally try to enunciate, pronounce my words correctly. But a lot of influences come from my time when I lived in California. I went to Canyon High School, home of the Comanches. No, I don't think that's still the name, but that's what it was back then, and a lot of fun. So it was during my teen years, and I still held a little bit of that. You know, I used to call people dude, no, right, chaw. I used to say all those things. It was the same time as Fast Times at Ridgemont High was being filmed, not too far away. And I was in Anaheim Hills, so it was a lot of fun. But yeah, anyway, you can probably tell by the accents anyway, we're not American. We are living in Australia. We have kind of, for Australians, Meckie, I think we have a very general accent, a very broad, not Australian-esque.
I don't know what you're talking about, you crazy fool. What?
You know, officially, I'm supposed to hate you.
Fairly neutral.
Oh, too many fun things we can do with our voices. But yeah, so look, we are Australian, and we love it. All the way down here in the world, upside down, or maybe you guys are upside down. I don't know. Because is there really a right way up in space? I'm going to ask you.
Yeah, sure. Whatever way I'm facing is the right way up, Dave. Just so you know. Okay.
So if you,
what a ridiculous thing, isn't it?
I know, right? If you're flying a spaceship anywhere in the universe, how would you know that you're right side up? You don't. There is no up and down and left and right and back and forth. Just wherever you are is where you are. Now, Meckie, so we've been talking about the hypothesis and the epiphany, which we've been building over all this time since we've started broadcasting, certainly from the 100th show, and that was, we were supposed to get to 100. So we're talking about telomeres and telomerase, and carried on from last week, where we discussed what there was in regards to the discoveries of telomerase and how that can, the presence of it in your body, telomerase, will grow back your telomeres. Now, if you don't know anything about that, we do ask you to go back to the last show. Maybe listen from 600, 601, and 602. Right, today's 602. So maybe you can catch up by listening to the last 2 hours. But Mackie, how about you take us on the journey, the latest news on telomere and telomerase research?
Absolutely. Now, this article is from 2018, and next week I'm going to bring you some more on that. So it'll be a little bit of a hard back, but right now I'm following an article that has caused me some controversy, and I don't want to share it until I've gotten to the bottom of it. Oh. They've used a sample group of 17 people to say that long telomeres are really, really bad for you. Now, this is extremely long telomeres, which are not normal for everybody, but in these 17 people, it seems to have a negative effect. Now,
that doesn't sound like an extensive research project.
Not 17 people, no. But the point is that it doesn't apply to the vast majority of people who have regular sized telomeres, as it were, right? But let's just see what this article tells us. This is from 2018, and the source is the Arizona State University. Hidden secret of immortality enzyme telomerase, quite prosaically named. And the subtitle here is, can we stay young forever or even recapture lost youth? So, research from the laboratory of Professor Julian Chen in the School of Molecular Sciences at Arizona State University recently uncovered a crucial step in the telomerase enzyme catalytic cycle. This catalytic cycle determines the ability of the human telomerase enzyme to synthesize DNA repeats, specific DNA segments of 6 nucleotides, onto chromosome ends, and so afford immortality in cells. Understanding the underlying mechanism of telomerase action offers new avenues toward effective anti-aging therapeutics. Typical human cells are mortal and cannot forever renew themselves, as demonstrated by Leonard Hayflick. A half-century ago, human cells have a limited replicative lifespan, with older cells reaching this limit sooner, of course, than younger cells. This Hayflick limit, which we discussed, of cellular lifespan is directly related to the number of unique DNA repeats found at the ends of the genetic material bearing chromosomes. These DNA repeats are part of the protective capping structures termed telomeres. And they really are protective capping structures, it's actually nicely put here, which safeguard the ends of chromosomes from unwanted and unwarranted DNA rearrangements that could and often do destabilize the genome. Each time the cell divides, the telomeric DNA shrinks and will eventually fail to secure the chromosome ends. It's like a fraying kind of thing effect happening. This continuous reduction of telomere length functions as a molecular clock that counts down to the end of cell growth. A clock, kill switch. The diminished ability for cells to grow is strongly associated with the aging process, with the reduced cell population directly contributing to weakness, illness, and eventual organ failure. Dave.
The fountain of youth at molecular level. Counteracting the telomere shrinking process is the enzyme telomerase that uniquely holds the key to delaying or even reversing the cellular aging process. Telomerase offsets cellular aging by lengthening the telomeres, adding back lost DNA repeats to add time onto the molecular clock countdown, effectively extending the lifespan of the cell. Telomerase lengthens telomeres by repeatedly synthesizing very short DNA repeats of 6 nucleotides, the building blocks of DNA, with the sequence GGTTAG. That'd be a good band name. No one could ever remember what it was. On to the chromosome ends from an RNA template located within the enzyme itself. However, the activity of the telomerase enzyme is insufficient to completely restore the lost telometric DNA repeats, nor to stop cellular and pulmonary fibrosis have been genetically linked to mutations that negatively affect telomerase activity and or accelerate the loss of telomere length. This accelerated telomere shortening closely resembles premature aging with increased organ deterioration and a shortened patient lifespan from critically insufficient cell populations. Increasing telomerase activity is the seemingly most promising means of treating these diseases. While increased telomerase activity could bring youth to aging cells and cure premature aging-like diseases, too much of a good thing can be damaging for the individual. Just as youthful stem cells use telomerase to offset telomere length loss, cancer cells employ telomerase to maintain their aberrant and destructive growth. Augmenting and regulating telomerase function will have to be performed with precision, walking a narrow line between cell rejuvenation and a heightened risk for cancer development.
Stop 1 second.
I'm stopping.
What this article is implying is that telomerase activity causes cancer or it causes cancer to occur. That's what it seems to say here.
It's suggesting those two together.
Yeah. Now,
inferring it.
What actually happens, and again, happy for anyone to tell me I've got a.
I've confirmed this with the doctor as well.
Yeah.
They're going to state the same thing.
Yeah. What actually happens is that now telomerase is switched off in most of your body. Not everywhere, but in most of your body. Your mouth, for example, still is. Anyway, but the point is, it's switched off. When a cancer cell develops, which usually happens because of maybe a fault in copying itself or some other environmental factor that damages the cell, whatever the cause may be, as soon as the cell is damaged and gets to a precancerous or cancerous state, it switches on the telomerase enzyme activity in order to protect its telomeres of the damaged cell. It's not that telomerase causes cancer to occur, or at least that's not the way I understand it. Cancer happens. Once the cancer happens through some mechanism, it switches on telomerase, right? Now this is actually the way the whole thing hangs together is really quite astounding. So people call it a molecular clock or even a kill switch, a programmed cell death. The word program is being used, right? As though nature decided. Nature is not a person, okay?
That's right.
Nature is an abstract concept describing natural processes. So there's nobody sitting there with a long beard and an eraser and a pen making the rules. Okay, if we take the scientific view, that doesn't have anything to do with religion or anything like that. So these things seem to follow a purpose, and the purpose is to end our life at a certain time, and that time is the Hayflick limit, which seems to indicate that we can't live very well beyond the age of 100 or 120 thereabouts. Now that's a completely unnatural state for us. Oh, Mackie, why do you say that? Because programmed cell death, molecular clock programmed to make our cells age and die. Now, if you switch that clock off, if you do away with the Hayflick limit, then why couldn't we live in good health until a very old age? Now, I'm not saying that you achieved immortality here, because you can still die if you fall off a rock.
That's
okay?
right.
But at the very least, we wouldn't be aging. And if you look after yourself, you don't take any unnecessary risks, etc., then you could live a very long life indeed. And if you had the technology that protects you, God knows what, maybe personal shields, who knows what. The point is that you could make yourself quasi-immortal. And we know, this is going to, sorry, but I have to bring this in here. We know that ancient peoples talk about their gods and god kings living for hundreds of thousands of years. Now, sorry, let's go back to the text, Dave. I apologize for interrupting.
Just have a look at what Amiga Logos has written in the chat.
Okay.
So I'm going to agree with you about the cancer cell that actually switches on telomerase, so it can't be killed, or like it's going to live forever. That's what it does. That is a thing. So yes, I suppose the inference here that they're connected together. That if you have telomeres growing using telomerase, that you'll get cancer. It'll just turn it into cancer. That's not the truth. So anyway, distinct from human stem cells, somatic cells constitute the vast majority of the cells in the human body and lack telomeres activity. The telomerase deficiency of human somatic cells reduces the risk of cancer development. As telomerase fuels uncontrolled cancer cell growth, therefore, drugs that increase telomerase activity indiscriminately in all cell types are not desired, says the author of this story, not us. Toward the goal of precisely augmenting telomerase activity selectively within adult stem cells, this discovery reveals the crucial step in telomerase catalytic cycle as an important new drug target. I smell money being made here, Mickey.
Oh, yeah.
Small molecule drugs can be screened or designed to increase telomerase. The activity exclusively within stem cells for disease treatment, as well as anti-aging therapies. Remember, therapy is not a medically defined thing. It's just a therapy. You're not actually doing it. It's like your skin therapy with the things you put on your skin to make it soft. It's not really a thing. Without increasing the risk of cancer. This is what they say. All right. Now that's the end of the statement. But I'm gonna say, Meki and I have spoken at length about CRISPR, and Amiga Logos has posted there that they increase the lifespan of mice. Chinese scientists did that by 25%. And yes, you can. And part of the story that we'll get to is that Meki's alluded to this already in the show, and that is about we have a designed life limit. It appears to be designed. And if you go back to the ancient texts, they do talk about that, not just the Bible, and it's 120 years, even though they say it in there as 120, even though at the time people weren't living anywhere near that kind of length.
The number of the counting shall be 120. 121. Not 119. 118 is right out.
I rewatched that the other day. All right, Meki, so what do we got next?
Yes, this article is, or not article, it's really a scientific paper, and we haven't got it in full here because it's just too long. And from June of 2021, and it's titled "Potential of Naturally Derived Compounds in Telomerase and Telomere Modulation in Skin Senescence and Aging." So skin cell death really is what it is. That's talking about it. And your skin renews itself on a regular basis, as you might know. You don't have the same skin you were born with. How about that? Mm-hmm. And this paper was written by Barbara Yashchuk, Blажej Rubish, and Eva Toton from the Department of Clinical Chemistry and Molecular Diagnostic at Poznan University of Medical Sciences in Poland. Poznan, in fact, that's where my mom is from, Poznan. Oh. It's called that. Anyway, that's not why it's here, though. Now, the abstract. Proper functioning of cells, their ability to divide, differentiate, and regenerate is dictated by genomic stability. The main factors contributing to this stability are the telomeric ends that cap chromosomes. See, they all use the same language. I love that. Telomere biology and telomerase activity have been of interest to scientists in various medical science fields for years, including the study both of cancer and of senescence and aging. Again, senescence is cell death. All these processes are accompanied by telomere length modulation, maintaining the key levels of telomerase component HTERT expression and telomerase activity that provide optimal telomere length, as well as some non-telomeric functions, represents a promising step in advanced anti-aging strategies, especially in dermocosmetics. That's of course, keeping your skin young. Some known naturally derived compounds contribute sufficiently to telomere and telomerase metabolism. However, before they can be safely used, it is necessary to assess the mechanisms of action and potential side effects. This paper focuses on the metabolic potential of natural compounds to modulate telomerase and telomere biology and thus prevent senescence and aging. Now, this is a paper from June 21. If you want to look it up, go ahead, knock yourself out. I will send you the link if you want, and I'm also putting the link into the chat. But what it says here is there seem to be natural compounds which aid in telomerase activity or stimulate it potentially and modulate it, and maybe in such a way that it can be used very targeted for anti-aging regimes. Now, the next bit is really, really, really important, and this is the role of stress, Dave.
Oh, yes. Telomere time, why we should treat biological age cautiously. This is the role of stress and fear. The study of Martins and al. Shows that the telomere lengths, or TLS, of newborns and their placentas were associated with the social economic status, or SES, of their parents. They argued that this finding could partially explain the well-known association between your social economic status, or SES, health and longevity. In landmark work nearly 2 decades ago, and this was from 2020, Eppel et al. Found that the average telomere length was shorter than expected in individuals as the extent of caregiver stress increased. The association between stress or adversity and average telomere length of circulating blood or saliva cells has been repeatedly demonstrated in diverse contexts since the work of Eppel, and many researchers have construed telomere shortening relative to chronological age as evidence of biological or advanced biological aging, cellular aging, weathering, susceptibility to disease, and even decreased potential lifespan. However, the complexity of this phenomenon is such that the biological mechanism of contextual telomere shortening is still not established, despite 2 decades of research. We can conclude there is a very early, i.e. at birth, association between SES and TL. And this is consistent with the observation that TL shortening relative to the overall population is associated with later declines in health and well-being. It is not clear what is added by postulating an intervening construct such as biological age to explain these findings.
There's another article which I will add next week as well, which actually quite clearly stated that a lower socioeconomic status of your parents led to shorter telomeres when you were born. So you're starting off with a disadvantage already. Whereas if you look at let's look at the royals, for example, right? They live very, very long. All right, and the thing is, that's because they're born with better DNA. I know how this sounds. I get it, but they are born with better DNA because of their ancestors and the stress-free life that those ancestors lived. And I'm talking about everyday stress here, obviously.
So everyday stress, also, man, just as an aside here, you can age rather quickly if you're under a lot of stress.
Yes, correct. Yes, yes. Gray hair and all that, right?
Yeah, it can all kind of come on suddenly if you're, if you're exposed to a lot of either fear, like direct fear, or just frightened, socially scared, or mentally challenged in an environment that you've really got to try to excel at to make it. So all of these things, your nervous system, how you feel, just how you feel is important to how quickly you age.
That is absolutely.
So if you didn't have a single worry in your whole life, neither did your parents, you'll live quite a while.
It's 100% correct. And just look at all the fear and uncertainty there's so
in the
into our
last
lives.
few years. Yeah, I know.
Now, there'll be more to this to add next week, so we'll take a step back, but that's okay. But for now, let us focus on the age of humanity at large. So I think we have established that human beings, in and of themselves, should live a lot longer than they do. And there seems to be a kill switch built in. That seems to be the case. Okay, and in fact, scientists are saying it's programmed to die. It's a molecular clock that's counting down. So it does. And I know scientists will say they don't mean it that way, but it does speak to a planned approach here. Let's just call it that. To our lifespan. But what about humanity? How old are we? How old is Homo sapiens? Now, the scientifically accepted number is about 300,000 years. However, last week, there was a really interesting, this is mainstream science, and I'll talk about non-mainstream science after that. There was a very interesting article across the entire scientific literature, okay? And this is around a structure that was found, a wooden structure called the Lincoln Logs, which is about 500,000 years old, 476,000 to be precise, which seems to have been part of a platform or a bridge or foundation of a house or something. Interlocking timber, right? That's what they found. So it's worked wood, not just wood, stacked on top of each other, but worked so it fits together neatly, like in a blockhouse. Okay. And again, like I said, 476,000 years old. Now, what some scientists have said, this was before Homo sapiens evolved. They say, like I said, the accepted age is 300,000 years. But I haven't seen it written down anywhere, but I was listening to this interview with one of the scientists, and he said this, and it was a man, I can't remember his name. He said this. He said, so the interviewer said, well, who built it? I mean, Homo sapiens wasn't even meant to be around at that point. He goes, look, it could have been a pre-Homo sapiens hominid race, certainly, or it could have been Homo. And this is what he said. He said this, and I remember it almost verbatim. It could have been Homo sapiens themselves. We just haven't found the old fossils yet for these Homo sapiens.
Yeah, right.
We just haven't found their fossils yet. Okay. So he, being a true scientist, which I found remarkable, that's why I'm bringing it up, said, yeah. I mean, the structure is here. Yes, it could have been maybe built by someone other than Homo sapiens, but it could have been built by Homo sapiens. Unprompted. He said it unprompted. We just haven't found fossils old enough
that's a pretty
corroborate.
That's a good.
Now, this is, of course, nonsense. We have, but they're not being acknowledged as such.
That's a pretty good position to take, though.
Yeah, no, I think it's awesome.
Yeah.
I really do. Now, this was actually in Zambia. It was found in Zambia. And this is really... Now, it's a disruptive discovery, they say. And this is what Larry Baum, the co-author of the new study and archaeologist at the University of Liverpool, England, says. He says, I would never have thought that pre-Homo sapiens would have had the capacity to plan something like this. It is an important window into what these humans were capable of, Annemieke Milks, an archaeologist at the University of Reading in England, who did not contribute to the research, tells Mehdi Burakov of the Associated Press. Wooden artifacts typically don't survive for millennia because they break down, disappearing from the historical record if they're not well preserved. But in this case, the researchers think that water may have protected the wood, which was discovered near a waterfall in Zambia.
Oh, this is the interlocking...
Yeah, that's
beams.
the one.
Yeah, that's right.
That's the one. Yeah, that's the one, brother.
Yeah,
100%.
yeah.
So, okay. Just think about that for a second. And there's a gap between that find and the next find, right? Which is only about 9,000 years old. Wood. I'm talking about wood.
That's right.
Wood doesn't survive very well, right? Now,
Yes.
so is it possible that humanity is a lot older? I want to put here that yes, absolutely, and slowly. And I said this. Remember, we did this show about how old the human race is, etc.
Yeah.
Many years ago, and I said this. We will find every year there will be more evidence pushing it further and further back. When I was a child, Homo sapiens was about 100,000 years old.
That's right.
So it was never. So it did coexist with Neanderthal, but Neanderthal was seen as an ancestor that we displaced, which now we know is complete nonsense. We were actually cousins or brothers, for that matter. You know, interbreeding, living at the same time.
Cohabitated. That's right.
100%. So, but let's just see. Let's just see where we are from an accepted point of view. Now, when did we become fully human? Is the title of the article. What fossils and DNA tell us about the evolution of modern intelligence? September 9, 2020, by Nicholas Longridge, senior lecturer in evolutionary biology and paleontology at the University of Bath. Bones of primitive Homo sapiens first appeared 300,000 years ago in Africa, he says, with brains as large or larger than ours. They are followed by anatomically modern Homo sapiens at least 200,000 years ago, and brain shape became essentially modern by at least 100,000 years ago. At this point, humans had brain cases similar in size and shape to ours. Assuming the brain was as modern as the box that held it, our African ancestors theoretically could have discovered relativity, built space telescopes, written novels, and love songs. Their bones say they were just as human as we are. Because the fossil record is so patchy, fossils provide only minimum dates. Human DNA suggests even earlier origins for modernity. Comparing genetic differences between DNA in modern people and ancient Africans, it's estimated that our ancestors lived 260,000 to 350,000 years ago. All living humans descend from those people, suggesting that we inherited the fundamental commonalities of our species, our humanity, from them. I like it when scientists say that we don't know.
Mm-hmm.
I love that. So thank you. I'm sure you're Dr. or maybe not, Nicholas Longridge. Thank you very much for that. Dave?
Southern African ancient genomes estimate modern human divergence to 350 to 260 years ago. Excellent. Karina M. Schulbusch. This is from the 3rd of November 2017. It's volume 358 if you're interested. Issue 6363, pages 652 to 655. Of Science, by the way. Ancient DNA pushes human emergence back. Anatomically, modern humans evolved in Africa, says the article. But pinpointing when has been difficult. Schulbusch and all, associated with the research, sequenced 3 ancient African genomes from the Stone Age, about 2,000 years old, and 4 from the Iron Age, 300 to 500 years old. One of the oldest samples, sequenced to 13 times coverage, 13x coverage, appears most closely to resemble individuals from the present day San population. However, this individual seems to have lacked genetic contributions from other modern African populations, including pastoralists and farmers, which were observed in modern San individuals. Thus, the earliest divergence between human populations may have occurred at this great number of 350,000 to 260,000 years ago. And the abstract says, Southern Africa is consistently placed as a potential region for the evolution of Homo sapiens. We present genome sequences up to 13 times coverage. from 7 ancient individuals from KwaZulu-Natal, South Africa. The remains of 3 Stone Age hunter-gatherers about 2,000 years ago were genetically similar to current-day southern San groups, and those of 4 Iron Age farmers, 300 to 500 years old, were genetically similar to present-day Bantu language speakers. We estimate that all modern-day Khoi-San groups have been influenced by 9 to 30% genetic admixture from East African Eurasians, or /Eurasians. Using traditional and new approaches, we estimate the first modern human population divergence time to between 350,000 and 260,000 years ago. This estimate increases the deepest divergence amongst modern humans, coinciding with anatomical developments of archaic humans into modern humans as represented in the local fossil record. One thing, Meki, that no one's talking about is the compression of our pairs from 48 to 46 pairs.
No, that's maybe something that we should,
we should hold paleontologists to the fire and get them to answer that question, because this time frame is also the same time frame of this divergence or convergence of DNA, which is written in the Sumerian text.
And since you went there, let's just examine that for a second. We do know that if you line up the the king lists, etc., of the Sumerians and Babylonians with that timeline, it would actually get you there, thereabouts. Right. Actually, a little bit beyond that, because don't forget, humans weren't made until the Igigi had been, slaving away for quite some time. Yeah. So
too much.
So it goes back. Yeah. So it's really interesting. Excuse me. If you compare the timelines, so, and again, bear in mind that we probably are not that race of people which was destroyed in the Cataclysm.
No, that's right.
We're the next iteration.
We're the next one.
But always bearing in mind also that we are just like the Igigi or the Anunnaki, as it were.
We were still made in their image.
100%.
But the first group were a mix.
Yes. Using their genetic material with stuff they found locally in the earth.
That's right.
If you go, because look, the Bible says we were made out of clay or mud or whatever, right?
Yep.
The Sumerian texts are a lot more detailed, descriptive. Where yes, we were used. There was clay used, like earth was used. Let's call it that, like material from the earth.
But it included their spittle, which includes their DNA. Yep.
And their DNA. So both. And so what this means, so in my estimation, is that what we call Bigfoot and Sasquatch, Alma, etc., were taken, and that DNA was combined with the Anunnaki DNA. Again, my opinion only, and to produce us more or less
but
really in many ways less.
The people they made were ageless. They didn't age. They lived forever.
Yeah, and they were quite different. But bear in mind though that the Anunnaki are not alien to us; they're us.
That's right.
Okay, and which is interesting, because if you take it a step further, and you have to with this, let's say they did combine their DNA with existing DNA of, let's say, Sasquatch. That means that they also cannot be alien to each other.
Yes, right? That's a good point.
There must be a deep link between those two populations. And again, I'll say that it is the inner earthers that we're talking about here. And when I say inner earthers, I don't mean they're just living in the cave all their lives. They're also spacefaring, believe it or not. I know, it's all too much, it's all too crazy, but if you follow the data, that's where it leads you. And I treat everything as data, including mythology,
Yeah.
ancient texts, especially if it's so detailed, and seems to indicate knowledge well beyond what they should have had, or well beyond what we assign them as appropriate, which is funny, really. What do we know? it's like telling Dave, no, what you wrote in your book is not true, Dave.
Oh,
it's
that
my
happened.
life.
That
no,
happened.
no, Dave, just not true.
Yeah, thanks for the person who said that, and it's very funny. So, what about the dates in which we can find these?
Yes, that's interesting. So this is the sort of deadline that's accepted today, okay, and we'll take them one to one. And again, bear in mind this is the accepted scientific stance as of pretty much now. Fossils attributed to Homo sapiens, along with stone tools dated to approximately 300,000 years ago, are found at Jebel Irhoud in Morocco, and they yield the earliest fossil evidence for anatomically modern Homo sapiens. Modern human presence in East Africa at about 276,000 years before the present, more or less. Bearing in mind that this is ignoring all the other finds that were listed in Cremo's work. Go ahead.
177,000-year-old jawbone fossil discovered in Israel in 2017 is the oldest human remains found outside Africa.
Correct. However, in July of 2019, anthropologists report the discovery of a 210,000-year-old remains of a Homo sapiens and 170,000-year-old remains of a Homo neanderthalensis in Apidemia cave in Peloponnese, which is in Greece, which is more than 150,000 years older than previous Homo sapien finds in Europe.
Neanderthals emerged from the Homo heidelbergensis lineage at about the same time, 300,000 years ago.
Patrilineal and matrilineal, so father and mother lines, most recent common ancestors of living humans, roughly between 200 and 100,000 years ago, with some estimates of the patrilineal MRCA somewhat higher, ranging up to 250 to 500,000.
Wow. Homo sapiens idaltu in Ethiopia, a Wash River near present-day Hetero village, practiced mortuary rituals.
Correct. This is a really interesting story that I heard around when did human beings first become civilized. And was when they built cities, when they started navigating the ocean, when they had indoor plumbing, etc., etc. But this anthropologist, I forget the name, said no. It stuck with me. The first time we showed signs of civilization was when she found this skeleton of a man who had broken his femur. But it was set, it healed, and he had lived a number of years after that.
Oh, nice.
So she said, this kind of injury you can't fix yourself. Mm-hmm. So the group, helped him be nursed back to health. Mm-hmm. His leg was healed, and that, in fact, when we started to care for each other in this way, is when civilization truly started. Now, there may have been many other instances where this happened, but this is the earliest evidence of that we had at the time, right? Okay, which brings us to 130 to 80,000 years ago, the marine isotope stage 5, and modern human presence in southern Africa and West Africa, as well as the appearance of mitochondrial haplogroup L2.
So when we spoke about SANS earlier and L2, they're the haplogroups.
Correct.
80 to 50, that's 1,000 years ago. MIS4, beginning of the Upper Paleolithic. Early evidence for behavioural modernity, appearance of MT haplogroups M and N, southern dispersal migration out of Africa, you might have heard that phrase before, Proto Australoid people of Oceania, and the archaic admixture from Neanderthal in Eurasia, from Denisovans in Oceania, with trace amounts of Eastern Eurasian, and from an unspecified African lineage of archaic humans in sub-Saharan Africa, as well as an interbred species of Neanderthal and Denisovans in Asia and Oceania.
We are interbreeding.
Yeah, it's just one big key party, Mackie.
You still have to be a child of the 70s to understand that. But I'm gonna. This is the perfect time for me to postulate once again.
Oh.
I think, one, that our ancient history and our diversity as a species, Homo sapiens I'm talking about, was much, much greater than we can imagine. And I think that stories of giants and little people and blue-skinned people and people with one eye and all kinds of strange and wonderful people, if you will, are in fact true. They're true. Let me give you this as an example when it comes to size. We know there are pygmy elephants in Indonesia and in Papua New Guinea. We know there are mammoths, which were much, much larger than modern-day elephants. We know there are very small sharks. They're still sharks, and we know they're very, very big sharks. Megalodon, for example, from the two movies recently with Jason Statham, is it? Now, it's true, those sharks existed. They were massive, huge, but they're still sharks. Why do we have such a hard time imagining ourselves variously sized, from quite small, let's say, to very large? There really isn't anything that would stop us, because DNA would just switch on, certain things, and we do know that bones can have different structures. I mean, birds fly more easily because their bones are hollow. They're very different to elephant bones, which have to support a lot of weight, for example, right? But it's supported nonetheless. Would it make sense for these gigantic humans to have lived in or near water? Sure it would. Maybe they did, right? And what about tiny human beings? Well, why not? I mean, we have
them. We have them today.
We have very, very small. I mean, we're talking like small human beings, but why not even smaller than that? What is? I mean, there's nothing really that would stop it functioning. I mean, you look at an ant. An ant. Look at an ant.
I'll look at my aunt with the hairy lip.
You better look at your aunt. You look at an ant, and it's a fully functioning organism.
That's right.
Right. Which is capable of great feats of cultural achievement, such as city building and farming, and caring for the young, etc., etc. So these it's instinct. Yeah, okay. I'm not saying it isn't. My point is they're tiny, and yet they're able to do that.
Oh, even a hummingbird, for that matter, Mackie. If you look at that,
yeah.
The brain is smaller than my little fingernail.
Right, and that's really the point here. And look, we're still the jury's out on the purpose and function and maybe even usefulness of a brain, because of the fact that people that had large sections of their brain missing could still function normally.
And the guy that didn't have any discernible brain was still a person and could talk and interact, and you didn't know. It was a surprise to find out that he didn't have a brain. It's
crazy if you think about it. It makes no sense. I mean, it goes against everything we believe we know.
He had the lizard brain component, right? And his pineal gland, and he had those, pituitary and everything, all those glands. But so the only thing was all of that large mass, the surface area that's all rippled, that's within our skulls. He didn't have any of that.
Now, that's astounding, to say the least. So the variety of human beings was much greater. And again, we know there are human beings that have blue skin. In modern times, there was a family in the States, we spoke about that, that had blue skin. We know there were green children that were found in the Middle Ages. We actually called the green children of something or other in England.
Oh, I remember that story.
Yeah, and no one really knew why or how or what. And many other like stories of the small little people. They found villages and tunnel systems for tiny people.
Yeah.
For tiny people.
So, Mackie, just thinking about right now on Earth, a cross-section of all of our existence, of not necessarily, just call it humanity for that purpose, right? So, yes, we have a tremendously diverse range of humans on the planet now, and they're all genetically compatible with each other.
Yes.
Back then we were too, because if you get your DNA scanned by any of those, places that can do it, they can break down your components of these things we've just read out.
Yes.
How much Denisovan, how much Neanderthal, whether you're, Eastern Eurasian or, from Africa, how much of that makes you as a pie chart. So we have ancestry. We were genetically compatible. And that's still the thing that gets me, is that if we were so diverse then, how would it be possible? And that just keeps me going. That keeps me up at night.
Because right now we seem to be diverse, but in actual fact we're a lot less diverse than we were. Right?
In fact, there's so little difference between us now that I've heard that we shouldn't even call them races.
No, correct. These are you're 100% correct.
Mm-hmm.
That's actually the truth. Now, some differences are greater than others, but overall the similarities are such that it's really just one Homo sapiens race.
We have all the same organs in the same places, Mackie.
Pretty much, yeah. And I don't think that was the case necessarily in the past. So again, I think vast differences existed in size, in color, maybe even in other things, in thinking, possibly in culture. So all these stories of ancient times, of the talk of all these different peoples, which we now call monsters and demons, etc., and gods maybe, I think they're largely true. I really do.
Those fables and fairy tales, Mackie.
Yeah. And not only that, so that's point number one. Point number two is that I think a lot of them have survived to this present day. And they have survived for a number of reasons. I guess they're good at hiding from us, which you should do. But also because I think some of them are able to use technology and maybe other things that we wouldn't necessarily call technology to evade us, specifically us. Because we know there are stories of portals and passageways when we talk about the little people, when we talk about Bigfoot, Sasquatch, etc., etc. And all these stories that lead you to other realms,
and
to other
fairies
places
at
underground.
the bottom of the garden, Mackie.
Bingo, right? And some of them might be slightly out of phase. Some of them might move too fast so we can't see them. Some of them might move so slowly that we don't even recognize them as what they are. And that sounds crazy.
Because why should everything be human-sized?
Exactly.
To our scale, our speed. Did you know, Mackie, that when the smaller we get, the higher pitch our voice is, because we don't have the length of our vocal cords. And the smaller you go and the higher pitch it is, we wouldn't be able to communicate very well with those.
No.
They would just hear these, they would feel these booming sounds that we'd make, and we wouldn't be able to discernibly hear. They might be speaking above 20 kilohertz.
And just think about this for a second. So I know people. You know people. We are horrible. Like individually, we're actually not too bad, but as a group, we're horrible. And if there were
1 minute,
if there were human beings like us, a lot smaller or a lot bigger, what would we do? We would do what we actually did in the stories. We'd kill them. We kill them. That's why, because that's who we are. It's just. Of course, you would hide away from us. It'd be insane not to, right?
We'd end up in a mantelpiece, Mackie.
That's I know, but that's it. Yes, I know. What? Insane.
Someone's log cabin. It's like that. Remember that video we saw on YouTube of the guys that found these small people in the forest?
Yeah.
It looks so unbelievably real.
they haven't I've watched a number of documentaries
Yeah.
on this, and it's not a fake video. It's
Yeah.
a video.
Yeah. Well, there's the music. Hey, thanks for being with us and inviting me into your lives. Stay tuned. Coming up next is Jer Bear with his awesome show After Hours. Hopefully he makes it. I don't see him in the chat room, but I'm sure he'll be here. And next, coming up the next time you can hear us is on Plato's Cave, 7 a.m. both Tuesday and Thursday mornings Eastern in the US. And in the meantime, take care.